How do we find derivatives of inverse trig functions? Well, hopefully you understand what inverse trig functions are already. What they're saying is if y equals arcsine of x, then there must be some angle y whose value of sine is x over 1. Okay, so here's my angle y. The opposite side is x, the hypotenuse is 1. And by the Pythagorean theorem, we can say that this leg is 1 squared minus x squared. So let's do implicit differentiation. The derivative of the sine of y is cosine y, and since that's a function in terms of y, we're going to multiply by y prime, and the derivative of x over 1 is 1. Solving for y prime, I get 1 over the cosine of angle y. Well, looking back at our triangle here, cosine of angle y here is going to be the adjacent side over the hypotenuse. That's 1 over the square root of 1 minus x squared. And we have just figured out the derivative of the inverse sine or the arc sine of x. It's 1 over the square root of 1 minus x squared. So, there it is in nice typed out form for you. Now it's your turn. I'm going to suggest that you pause this screencast and see if you can figure out what the derivative of arc cosine of x is. If y equals arc cosine of x, what is y prime? So go ahead and hit pause, draw a triangle, and see if you can figure it out. Okay, think you've got it figured out? Here's what you need to do. Your triangle is going to have angle y down here. Since the cosine of angle y is x over 1, that means that this adjacent leg is x, the hypotenuse is 1, and that makes the opposite side the square root of 1 minus x squared. So we're going to take the derivative of both sides using implicit differentiation, and I'm going to have negative sine y times y prime equals 1. So y prime is negative 1 over sine y. And going back to our triangle, sine is opposite over hypotenuse. So it's negative 1 over the square root of 1 minus x squared. So it's the same as arc sine of x, except it's negative. That's easy to remember, isn't it? Now let's do the same thing for arc tan of x. So that means that if y equals arc tan of x, then the tangent of angle y equals x. So here's angle y. The opposite side is x. The adjacent side is 1, which makes this the square root of x squared plus 1. Okay, so we take the derivative of this now, and the derivative of tangent is secant squared. We're going to multiply that by y prime. The derivative of x is 1. Solving for y prime, I get 1 over secant squared y. And the reciprocal of secant is cosine, so this is actually cosine squared of y. Okay, so what's cosine? Cosine of y is the adjacent side here over the hypotenuse, so that's going to equal 1 over the square root of x squared plus 1, and since cosine is being squared, I square that. And our final answer, if y equals the arc tan of x, y prime, is 1 over x squared plus 1. So you need to memorize these formulas. The derivative of the arc sine of x is 1 over the square root of 1 minus x squared. The derivative of arc cosine of x is negative 1 over the square root of 1 minus x squared. And the derivative of arc tan of x is 1 over 1 plus x squared. Let's do an example. So let's differentiate this stuff, okay? Since I have an x cubed times an arctan of x, we're going to have to use the product formula, product rule for our derivative. So that's going to be y prime equals 3x squared times arctan of 3x plus x cubed times the derivative of 1 plus whatever we're taking the arctan of squared times the derivative of what we're taking the arctan of, because we have to do the chain rule. So this is 3x squared arctan of 3x plus 3x cubed over 1 plus 9x squared. And that's as far as we can take it. So that's going to be our answer. That is the derivative of x cubed arctan of 3x. So remember, memorize these three formulas right here because we're going to be using them a lot when we're taking derivatives of inverse trig functions.